In this video, I'll demonstrate how to configure and how to scan for open ports. A port number in TCP/IP uniquely identifies a service running on a host, such as a web server listening on TCP port 80. Of course, communication back to a client happens on a higher level port. Some network services allow administrators to configure the listening port. Let's take a look here in our Windows server by going to the Start menu and searching for IIS. Then we'll start the IIS Manager tool, where in the left-hand navigator, I'll expand the name of our server, I'll expand sites, and then I'll right-click on the default website, where I'll choose Edit Bindings. Here we can see our web server has two bindings, one for HTTPS on TCP port 443, and another for HTTP on TCP port 80. So notice here on the right, we could either add new port bindings, also even tied to different IP addresses, if the server has multiple IPs, but we could also select an existing binding and edit it and change things like the port number if we really wanted to. Now, you might do that for additional security so that anyone that wants to connect to, for instance, a website with a different port number would have to have knowledge of that port number because it's not listening on the standard listening port. Now, at the same time, there are plenty of tools out there, both for Windows and Linux, that allow us to scan for ports. Here in Kali Linux, we can use the Nmap tool to scan either a network range or, in this example, a single host, in this case to see which TCP ports are open. What services is this host running? This is part of reconnaissance, whether it's used for legitimate purposes or whether it's used for evil. So the command here is nmap space dash lowercase s uppercase t for TCP, and then I've given it the IP address of our Windows web server. Now, when I press enter on that, after a moment, it'll give me a listing of open TCP port numbers, one of which certainly will include port 80 because we know that it is a web server. So we can see we have quite a list of open ports here, including TCP port 80 for HTTP. We can also scan for UDP ports. I'm going to use the up arrow key to bring up a command that I've run previously. I'm using nmap with dash lowercase s but an uppercase U for UDP. Then I'm using dash p to specify the port number I want to scan on a host. In this case, I want to scan UDP port 53, which is the DNS client listening port. So when I press enter, in fact, I can see that that specific port is actually open. So I know that that is a DNS server that is listening. And again, this is all part of reconnaissance. Now, we also have the option of scanning a range of machines for certain ports. For instance, if I were to type nmap space dash lowercase s uppercase t for TCP, and then I'll give it a range, 192.168.1, let's say .100 dash 200, and then press enter, it's going to scan for TCP open ports on all of those hosts. Once Nmap completes the scan, down at the bottom, I can see in this case it scanned 101 IP addresses where 8 hosts are up. And as I scroll back up through, I can see the IP addresses and the OpenTCP ports on each of those IP addresses. Now, sometimes you'll get fewer or more ports. It depends on what services are running on the machine and whether or not it's got a host-based firewall that limits what ports you can see. But either way, it's pretty easy to scan for open ports to see what's running. Now, from a malicious standpoint, the bad guys and girls will be interested in this information because if they see, for instance, that there's an FTP or a DNS server open on a host, they can then focus on that to determine what kind of FTP or DNS server is running and check out version information, find out what exploits are available, and then begin compromising systems in that manner. In this video, we learned about configuring and scanning for open ports.